Hi guys, tonight we're going to continue with linear functions, and in particular we are going to be looking at parallel and perpendicular lines. And this is one of my favorite puns. Parallel lines have so much in common, it's a shame that they'll never meet. Okay, so the first half of your notes, you had 2 pages of notes tonight, takes a look at lines A and B, and what I would like you to do is find the slope of the line A, the slope of line B, the y-intercepts of both lines, and then write the equation of line A and the equation of line B. And then, so pause the video, go ahead, find the slope, y-intercept, write the equation, and then start the video again so that you can check your answer. So first we're going to look at line A, which is right here. So we need to find the slope, so we know it's positive because it's going uphill, and we're looking at the rise over run, and the slope is 2 and 1. So the slope of this line is 2 over 1, and we can write the slope as 2. Next we want to find the y-intercept. The y-intercept is right here, and the y-intercept is 6, and we can also write that as 0, 6. So if we're going to write the equation of the line, it's y equals, the slope is 2 times x, and then plus the y-intercept. So it's 2x plus 6. Now we're going to find the slope of line B. Again, use 2 points from the line. It's the rise and the run. Slope is, or rise is 1, run is 2. So the slope is 2 over 1, which simplifies to 2. Then we're going to take a look at the y-intercept. The y-intercept is negative 4, and as an ordered pair, that's 0, negative 4. So if we're going to write the equation of the line, it's y equals, the slope is 2 times x, and we can write that as plus negative 4 or minus 4. So I want you to take a minute and look at these two lines. If you look at them on the graph, they're parallel. So how can we tell if two lines are parallel without graphing them? Well, let's take a look at the equations. We have y equals 2x plus 6 and y equals 2x minus 4. What do you notice about their slopes? The slope of line A is 2x, and the slope of line B is 2x. So if two lines are parallel, they're going to have the same slope. Y-intercept doesn't matter. What we care about is just looking at the slope. Now we're going to take a look at perpendicular lines. We have line A and we have line B. Same thing, go ahead and find the slope, the y-intercept, and write the equation of line A. Find the slope and the y-intercept of line B and write the equation for line B. Go ahead and pause the video and then check your answers. So the slope for line A, I'm going to use 2 points, and I can use any two. I'm going to use the y-intercept and this point over here, and my rise is 1, 2, 3, 4, 5, 6. And my run is 1, 2, 3, 4, 5, 6. And since this is going downhill, it's a nice negative, so my slope is negative 1. To find the y-intercept, where does it cross the y-axis? My y-axis, or y-intercept, is also negative 1, and I can write that as 0, negative 1. To write the equation of the line, just like we did before, it's y equals, the slope is negative 1, x, and then plus negative 1, we can also write that as minus 1. We can also write this as negative x minus 1. Same thing for line B. We have to find the slope. It's uphill, so we know it's positive. And I can pick any 2 points. I'm going to pick the point negative 1 to negative 2 and the y-intercept. The rise is 2 and the run is 2. And that simplifies to 1. The y-intercept of line B happens to be the same as line A, which is negative 1. And again, we can write that as 0, negative 1. Because it's the y-intercept, my x value has to be 0. So the equation of the line is y equals 1x plus negative 1 or minus 1. We can also write that as y equals x minus 1. So we take a look at these slopes. The slope of line A is negative, the slope of line B is positive, so these slopes are opposites. This one is a negative one, this one is a positive one. But they're also opposite reciprocals, and we'll see that a little better in the next example. Okay, using slope-intercept form, and again, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. How do we know when two lines are parallel? If two lines are parallel, and we said this in the last example, their slopes are the same. So they have to have the same rate of change, the same rise, and the same run. So we're going to find an equation of a line that is parallel to y equals 2x plus 1 and passes through the point 5, 4. So if we're looking for a line that is parallel, that means the slope has to be 2 because it has parallel slopes. I need a line that's going to pass through the point 5, 4, so that means my x value is 5 in this ordered pair and my y value is 4. And I need to find the y-intercept, just like what we did when we were writing equations a few days ago. So slope-intercept form is y equals mx plus b. I know what y is, and that's 4. I know what my slope is, and that's 2. I know what x is, that's 5. So now I can find b. And I get 4 equals 10 plus b. Subtract 10 from each side, and I get negative 6 equals b. So now that I know what b is, and b we said was negative 6, I have a slope of 2 and a y-intercept of negative 6. So it's a parallel slope, so that's 2x, that stays the same, and my y-intercept is negative 6. So this line should be parallel to this line, and we're going to go ahead and graph them just to make sure we're right. So graphing this point, my y-intercept is 1. My slope is 2, so that means up 2 and to the right 1. It's a positive slope. Up 2 and to the right 1. I can also go down 2 and to the left. I can go in the opposite direction. So down 2 and to the left 1. So when I connect my line, that line is the line y equals 2x plus 1. So now I want to graph the parallel line to see if it is parallel to 2x plus 1 and does it pass through the point 5, 4. So my y-intercept is negative 6 and my slope is up 2 and over 1. Up 2 and to the right 1. Up 2 to the right, and keep on doing that till we run out of the graph. And if we look, lo and behold, yes, these two lines are parallel. So does it pass through the point 5, 4? So let's take a look. I want to know, does it pass through the points 5, 4? So here's the point 5, 4. There's the point 5, 4 right there. So yes, it does pass through the point 5, 4. And it is parallel to the line y equals 2x plus 1. So if two lines are parallel, their slopes have to be the same. So now let's take a look at the second half of that page. How do we know when two lines are perpendicular? So we graphed the other two lines, or the lines, example 2 on the first slide. So how do we know if they're perpendicular? If two lines form a right angle, and have opposite reciprocal slopes, then they are perpendicular. So what do I mean by opposite reciprocal? So let's do a couple examples. So if I have the fraction 1/2, its opposite, this is positive, is negative. Its reciprocal is 2/1. If I have a slope of 2/3, if it's negative 2/3, its opposite is positive, and it's 3/2. So we would have slopes that look like this. This is negative 2/3, its opposite is a positive, and then we just flip the numerator in the denominator. So we're going to look for a line that's perpendicular to 2x plus 1. Well, this slope is 2, and we can write it as 2/1. If we want the slope of our new equation, I'm going to call that just m1 so we know what we're talking about. I'm going to flip this around, that's the reciprocal, and since this slope was positive, I'm going to make this slope negative. So the slope of my new line, of a perpendicular line, is negative 1/2. So I want to see if this new line with a slope of negative 1/2, if it passes, I want a line that has a slope of negative 1/2 and passes through the point -2, -2. So this is my x value and this is my y value. So the slope is negative 1/2. It's the opposite reciprocal of 2. My x value is negative 2, and my y value is also negative 2. So we are looking for B. So back to our slope-intercept form, y equals mx plus b. Y is negative 2. The slope is negative 1/2. My x value is negative 2, and we're looking for b. So we get negative 2, negative 1/2 times a negative 2 is 1. Subtract 1 from each side, and we get a y-intercept of negative 3. So our equation is y equals negative 1/2 x minus 3. So we're going to graph this equation, and we are going to graph this equation to see if they're perpendicular. And they should be, because their slopes are opposite reciprocals. So let's graph y equals 2x plus 1. There's my y-intercept. It's up 2 to the right 1, up 2 to the right 1, and I can go in the opposite direction as well. This is the same line from the previous example. Now I want to graph y equals negative 1/2 x minus 3. My y-intercept is negative 3. The slope is negative, so it's down 1 and to the right 2, down 1 and to the right 2. I can go in the opposite direction. I can go up 1 and to the left 2, up 1 and to the left 2, up 1 and to the left 2. So draw my line. Does it pass through this point? Does it pass through negative 2, negative 2? And yes, it does. Is it perpendicular to the line y equals 2x plus 1? Yes, it is. So now it's your turn. Are the two lines below parallel? So are they parallel? Are they perpendicular? Are they neither? Or are they both? So we want to find the slope of the first line and the slope of the second line and compare them. Number 2, write in slope-intercept form the equation of a line that passes through the point 2, negative 1, and is parallel to y equals 2x plus 2. Be sure to put your answers on the Google form.